Welcome back to the channel, for the first time not live effects, but me. It's time for another floating island episode. We look at the creation process of island roots. This time I took a completely different approach than Rohan's floating island. Again, I took a completely vex-driven approach, but the idea of the design still comes from Rohan's course. The island body has roots growing underneath it. There are some smaller ones growing alongside the surface and some bigger ones hanging down but then connect back to the surface. Combined with all the other elements, this will be a great addition. In this video we're going to start with the bigger roots hanging down and connect to the island mesh in a curve. So let's begin with a new geometry node, get rid of the file sub and create an object merge. Again we need the mesh of the island body. Let's hide the other stuff and concentrate on the geometry at hand. As I said, I want to create two different kinds of roots. For the thinner ones, I want to create starting points below a certain value on the y-axis. To do that, I create a blast node and address at p.y, and I want to get rid of every point that is not below -1. And if you are dealing with points, don't forget to switch the type of the blast node. On this surface we can scatter the points for the roots. Now for the thicker roots, I only want to use a small slice of the island. So I have to use two conditions. For those times I feel a wrangle is more convenient. So I create an if condition with at p.y bigger than -1 or smaller than -3. If the point is not in between that range, the point gets removed. And there we have our slice. This is not a clean cut, but for the task at hand it doesn't matter. We only need an area where the points can be scattered. So let's create a scatter node. For the smaller roots, 1000 points might be a good idea. For the bigger roots, however, this would be way too much. So let's try 50. Now that we have the starting points for the roots ready, let's jump into the vex logic to create them. I want to do the operation for each point individually. To do that, let's create a for each loop looping over the points. Let's template the mesh for reference and then create an attribute wrangle. So what do I want to create? I want to use each of the points the scatter node created and create a line that goes straight down but then turns into a curve that reconnects with the island mesh. As I said, I want to solve this problem with vex. To make that possible, I need to connect the island body to the second input of the attribute wrangle. First, let's create us some space and start up the editor with Alt-E. Each loop iteration starts with one point. The line is supposed to start downwards. So we have to set the initial point normal to -1 in the y-axis. After that, we take our current position, add the normal and save it in a new vector. And we use that vector to create a new point. Now each of our initial points has a counterpart exactly 1 unit lower. As with the vines, this will not look very natural, so let's bring in a random factor. For that we create a new float variable, dist for distance, and this variable will hold the result of the function random. The random function can use a vector as input and create a value from 0 to 1. We're going to use that to call a fit01 function to change the range of the result. For more control, I create two new channels for the min and max values of the fit function. After generating the UI element, I can type in any value and you can use it in your vex coding. Now the only thing you have to do is to multiply the normal with the distance variable. And now we should have a random length between the 2 points. But we need a third point that can connect the second point back with the mesh. So let's use addPoint, and to find the mesh, we use the function minPos with the second input as parameter. This will find the closest point on the mesh, and with addPoint we immediately create a new point at that location. Now if we set the visibility flag back to the attribute wrangle, we now have 3 points. When we manipulate the min and max values, the position of the third point is changing. It always tries to find the point that is closest to the second point. Now let's create another attribute wrangle. The first one created the new points, and this one is going to combine these points to a polyline. We already did this kind of thing with the vines. We start by adding a new primitive with the type polyline, and then one by one add vertices to the points. That connects all 3 points, and now you can very easily see how the position of the second point manipulates the position of the third one. Now if we take a look at all the roots combined, this is not a bad start at all, but I want to make a minor change to the setup. At the moment each root is randomized, but all of them go from 3 to 4 according to the min and max channels. I want the roots that start at the top to have the potential to be even longer. Basically, I want them to start at different locations and different levels on the y-axis, but on the bottom side I want them to have a somewhat similar level. For that I'm going to multiply the dist variable by a new channel I call mult. If I put a value in here, I can directly manipulate the length of all roots combined. But let's keep that at 1.5. But we are not going to use the 1.5 every time. First we're going to subtract another value. That value is based on a fit function using the position in y. We know that our root points are somewhere between -1 and -3. We are going to change that range to 0 to 1. -1 is now 0 and -3 is 1. It's almost there. Let's try adjusting the range of the fit function to -4. And that's more like it. And now it's time to create the curve. Create a pulley bevel node, set the type to points, increase the divisions quite a lot, and then push up the distance just far enough to create a nice smooth curve. Of course we also want to apply some kind of noise, and to make that possible we need more points. So let's use a resample node. In my case the default settings should be fine for now. But again, using the same technique as with the vines, I want to create a red gradient to manipulate the strength of the noise we apply after that. Again, for a color gradient, for the point numbers 0 to n, initialize the color attribute and then only fill the x component of the color vector. The formula is using the point number divided by the amount of points. Remember to cast these values to float to create a working value for the color vector. Now this creates the ramp from black to red, starting with point 0 being black and the last point pure red. But I want that to be reversed. An easy way to do that in Vex for 0 to 1 values is again the function fit01. Just override the x component of color and switch its range from 0 to 1 to 1 to 0. And when that is done, we can paste in an attribute wrangle we created in the last episode. This wrangle is creating a noise based on the color red. Now the amount and kind of noise is just a matter of taste. After you have applied the noise, we finally give the roots some thickness. For that, simply create a pulley wire with a wire radius to your liking. And as a last, very small adjustment, for most of the roots it doesn't look as if they would hang down from the body. Most of the roots just connect with the mesh in a straight line. To fix that, simply go back to the min-pos function and add something to the y component of the position. And there you have the thicker hanging roots of the island. In the following episode, we're going to create the smaller roots crawling over the surface of the island mesh. And with that, I see you next time.